Okay, adding and subtracting of radicals. Now we've been working with division and multiplication of radicals. We're going to still see some more of those as we go through, but as we expand on those ideas, get into special products and that type of thing, we have to be able to deal with adding and subtracting of radicals. So I have an expression here. 6 squared of x minus the cube root of 4 minus 5 squared of x plus 2 cube root of 4. I'm going to do a process here that hopefully you only need to do once, but if it's something that works for you, by all means incorporate it. I'm going to make a substitution. Okay, so what I'm going to do is where I see the square root of x, I'm going to write that as a. Where I see the cube root of 4, I'm going to write that as b. I want to touch on some information I know you already have, or retouch on some information. So where I see these, I'm going to put these. So this becomes 6a minus b minus 5a plus 2b. Now there is a they always say that if you are musically inclined, you are going to be relatively good at mathematics, or it's incorporated in there. There is a how do I say this? There is a rhythm as you go through, and there's an oratory hearing part of this that will help. So when I stated, if you go back through and watch it, you're going to start recognizing patterns. Okay, 6 squared of x minus cube root of 4 minus 5 squared of x plus 2 cube root of 4. Hopefully when you look at this, 6a minus b minus 5a plus 2b, the things that sound the same, hopefully you're saying to you that the old information that you have is, well, when I ask what do we do next, you're going to say, well, I'm going to combine like terms. Well, if you go back to that sound, the sounds that were made, 6 squared of x minus cube root of 4 minus 5 squared of x, the things that sounded the same, those are actually the like radicals. Well, here we know that the a's are the like terms. That's information you learn to know and I know. B's are the like terms. So if we went through and combined those, 6a minus 5a, we had a, negative b plus 2b is just b. If I ask you, why can't you add those, you would tell me, because they're not like terms. Okay, we know that. Well, it's not really what these are, right? I'm going to make the substitution back now. Again, this is something that as you go through, if you need to do to recognize this, by all means. I'm going to make the substitution back. I have square root of x plus the cube root of 4. Now hopefully that's the last time you would have to do this once I give you the information what to look for. We know these are not like terms and we can't combine them. We are going to understand that these are not like radicals and we can't combine them. For us to be able to combine in the manner that we did, when we look back to the original without having to convert, we need to understand what a like radical is. A like radical, they have the same index. Square root, cube root, cube root. This alone tells me that these are not like radicals. I wouldn't be able to combine them. Okay, but we could have a square root and another square root, but they are not like radicals. We have the same index. We also have the same radicand. The information underneath the radical. Square root, x, x. Okay, those would be like radicals. If this is a square root of x and this was a square root of y, they would not be the same. Well, when we do this, when you look back, 6 squared of x minus 5 squared of x. Well, what we actually combined here were the 6 and the 5, the coefficients. So if we have the same index and the same radicand, what we can combine are the coefficients. So if you recognize they are like radicals, combine the coefficients. Okay? So this gives us an introduction. In the next clip, what we'll see is we'll go through and we will do ones that are all like, or recognize what ones we can, and then we'll build on that.